If you had told me 2.5 years ago I'd be playing the same Minecraft world, still getting excited to every day, I don't think I'd believe you. I started this run of GregTech New Horizons January 2024, and we're now reaching July of 2026. In that time, I've learned so much about GTNH and have been through three major version updates. I've watched YouTube creators and Twitch streamers like Threefold get to tier 7, Hamcorp, Sol9, Cat's Cozy Games, all of whom reach Stargate. While I'm not quite as fast as getting to the end of the mod pack as they are, I've played over 2,900 hours at my own pace with both excitement and frustration. Now that I've made it to the later ages of the game, mainly UHV and UEV, space mining has become my primary resource generation mechanism. In this video, I'm launching a new method of managing space mining modules that are fully controlled with OpenComputers. So what does Medina actually do? So let me explain the idea first, because once it clicks, the setup will make sense. So in GTNH, the space elevator lets you mine asteroids with a space mining module mark 1, 2, or 3. You put a drone, drill bits, some rods, and plasma into a mining module, set a distance, and it pulls ores from space. The problem that we have is babysitting. Swapping drones, refilling drill tips, deciding what to mine next. Now, some of that can be handled with stocking input buses and stocking input hatches, but to be able to do that across 6 modules, it's a full-time job to keep up with ore processing. So Medina is the manager that does all of that for you. Here's the loop. You tell it what dusts you want to keep stocked. Say, always keep 100 million Infinity Catalyst dust in stock. This will watch your ME network. When something drops below your target, it figures out what is the best asteroid to produce it. It will then pick the best drone that you have available for that asteroid, grab matching drill tips and rods, load them into an input bus, set the distance on the mining module, and starts mining. When that job is done, it'll pull out the non-consumable drone from the input bus and we'll move on to whatever's next on this list. And it will do it for this use up to 6 modules at the same time from a single computer. This can support upwards of 27 mining modules in its ultimate form, but for the first release of this script, we're only going to handle up to 6 at a time, and it's really dependent on the number of components you have available in a component bus, which by default is 16 in a tier 3 computer. So one thing I want to call out, because it's the heart of why this version is fast, all 6 of these modules load their gear concurrently. The computer never freezes while it's waiting for one to complete. It will juggle all of them at once. And that's the difference between the initial version that I was working. So now let's talk hardware. There are 3 parts: the brain or the broker, the modules that make up the space mining control system, and the telemetry nodes. Let's talk about the broker computer first. This one computer runs everything. So it will need a tier 3 OpenComputers computer case. If you want to run more modules than the component bus limit in a tier 3 computer, you'll want to create a server in a computer rack with the higher tier component bus. Normally it will support 16, but if you want to get really creative, you can go to a creative component bus if you are far enough in the mod pack and handle up to 1024 components. As we can see, this is a little expensive, but if you are in solid UHV or UEV, you should be able to craft this no problem. The next components that we'll need are a tier 3 graphics card. This will run the 2 high and 3 wide tier 3 screen that will display the dashboard. We'll need an internet card to grab the files from GitHub. And we'll need a wireless network card tier 2. This will control a job node if you have the distributed version of this, and it will allow the telemetry nodes to report in on the inventory that they have as well. The other important thing that we'll need is an adapter with a tier 3 database upgrade. This is important and it'll be easy to miss, but this database will store item fingerprints for you so the system knows which drone and drill bits to pull. One database is shared across all of your modules. A basic one holds very few. The tier 3 will hold 81 item slots, which will allow you to handle 27 mining modules. Now that we've talked about the basics that are required on the broker side, let's talk about the mining module side. So for a single mining module, we'll need a few components. First one is an adapter with an MFU assigned to that mining node. In this case, this is a mining module Mark II. For the inventory loading, we'll need 3 components. We'll need an adapter that touches the ME interface. This will be the mechanism for drones, drill tips, and rods to enter the input bus for the mining module. The transposer is required to move those items from the ME interface into the input bus. Here I just have a standard EV input bus. You could go all the way down to an LV bus that has 4 slots. We'll only ever use 3. The way that this will work is the adapter will set the configuration for the Asteroid for the consumables. So in a tier 9 mining drone or tier 10 mining drone, for example, it will set the configuration on this interface to a single mining drone in slot 1, a stack of drill tips in slot 2, and a stack of rods in slot 3. Every mining module will need these 3 components, plus the adapter for the mining module itself. When you configure these, there's 2 ways of setting up the config for the computer. I provide a script that as you hook them up one at a time, it will generate the config file, or you can run your own method that you use to add components to the config. Either one is supported. Next, what we'll need are 3 monitoring nodes. I'll go over each of these. So on your fluid subnet, where you have your plasma that's required for the mining drone, we can see that I've got creative cells that have helium, plutonium, 241, and radon plasma that are available from the network. This computer is configured the same way. Graphics tier 3 case with a tier 3 graphics card, an internet card, a wireless network card tier 2. Tier 2 because we need to support up to a 400 block range on messages that get passed between the telemetry nodes and the broker. A CPU tier 3, 2 3.5 tier memory modules, and a 4 megabyte or tier 3 hard drive. This also has a tier 3 monitor attached to it. Disk drive is only used to install OpenOS, and we need a Lua BIOS EEPROM. Behind this computer, we have an adapter mapped directly to the ME controller so that we can get the items that are in the network. The second one is the drone and consumable subnet. This subnet contains all of the mining drones that we have available, as well as drill tips and drill rods. In this tutorial, I just have creative vending upgrades on a drawer, and I have a single storage drive for that. Again, tier 3 computer, EEPROM Lua BIOS, tier 3 graphics card, internet card, wireless network card, tier 3 CPU, tier 3.5 memory cards, modules, and a tier 3 hard drive. Again, drone and consumable subnet. Our third subnet is going to be a little more open. So in my world, I dump all of the output from the mining modules to an ore processing subnet, which then gets shipped out to the integrated ore factories. After those integrated ore factories are done, they dump out into the ore processing output subnet. Here, again, tier 3 computer, Lua BIOS, tier 3 graphics card, internet card, wireless network card, tier 3 CPU, 2 tier 3.5 memory modules, a 4 megabyte hard drive. Again, adapter touching ME network. Over here for the drone, consumable network, ME adapter touching, or adapter touching the controller. And this will generate the telemetry for what resources are needed to be mined. In this tutorial world, I did set up some integrated ore factories, but I didn't power them or turn on the processing for them because it takes a lot to demonstrate this. And so again, we have a dust telemetry node, which watches ore processing output. We have a consumable or hardware telemetry node for our drones and our consumable subnets. And we have a fluid telemetry, which monitors the fluid subnets for plasma. The screen is not required, but it is nice here because we'll see a dashboard of the data that is being sent to the broker. So let's talk hardware. This will assume that you have a basic familiarity with OpenComputers. If you don't, let me give you a quick tutorial on what you'll need. First off, you'll need a computer with the resources required to build the 3 telemetry nodes and the job broker. Before we get to that, we will need a computer with all the resources required, components required. I'll go over those in a minute, but first the machine has to be running OpenOS. The way to do that is to take an OpenOS operating system disk, put it into a disk drive, boot the computer up, and install OpenOS. Say yes here. And before we reboot, take disk out and reboot. We will repeat this task on each of the other machines. The fluid subnet telemetry node, the consumable and drone subnet telemetry node, and the ore processing output subnet telemetry node, or a node where you keep all of your dusts post-processing from ore. Okay, hardware's built. Let's get the software on. The good news is there's an installer, so you don't have to type a wall of download commands. On each computer, you'll grab the installer and run it directly from GitHub. wget and the file itself, and then run the install Medina command. Now, this install script will ask what computer node this is, whether it's a broker, a dust node, a hardware node, a fluid node, or a job node, or everything. It'll only download the files that the role will need. So on the broker, you'll pick broker. It pulls the main program, the engine, the configs, and the helper tools. This is a fluid telemetry node. So in this case, we're going to say number 4. And now we can run fluid telemetry. It's safe to ignore the set target side at the top of the fluid telemetry file. That is perfectly okay to ignore. And now we've run the fluid telemetry node. This will start reporting in once the broker is up and running. But you can see here that we've got helium plasma and radon plasma in our network, and the other plasmas that are eligible for the base mining module will also show up here if they are in storage. I have creative tanks with fluid storage buses, so we'll be able to see all of that. And this dashboard will just run in the background. Next, let's do the hardware node. Now for the hardware node, we're going to run that same install script. And this one is going to be number 3, the hardware node. And we'll run the hardware telemetry command. And we can see here that there is a bit of a display bug with rewriting the size of the availability of the number of items. I have infinite storage upgrades, creative vending upgrades on a storage drawer, so these will show as infinite. And I have a stack of drones for each level. Again, dashboard, we're up and running. We're sending network signals out over port 2026. And if we look in here, we can see that we have all of our inventory there. Next, let's do the ore processing subnet. We're going to run that same command again for a 3rd time. Do the install. This is going to be our dust node. And again, safe to ignore. Just run the dust telemetry. Because I don't have any dusts in here right now, it's only going to pull, it's only going to poll for the Infinity Catalyst dust, which I do have a couple of stacks there. So we're good to go on that one. Now this one is going to be slightly more involved. This is going to be the broker node that's got everything consolidated. Again, same install command. We're going to call this the broker. And it'll grab the required files. There are quite a few other required files here. And now we'll be able to run some of our commands here. Now, as far as the setup is involved, now that we've gotten all of our files downloaded, we need to do some work on the configuration file. So on the broker node here, I'm going to edit the configuration, and the way that this works is it shows a bunch of configuration values. So it lists the drones and their levels. It lists the levels for the best selection. So it goes from the highest to lowest. And it will map those to the specific drone levels. Here in the drill consumables, this is static. Again, you don't have to change this. This is the different sets for the various drones. We map the drone tiers to the different consumable materials. We set the parallels for mining. the amount of power and the max computation. So make sure that your optical reception connectors have the right amount of computation being sent to them. We configure our plasma overdrives, the order for best available plasma for tier selection. Yes, there is a typo in that, and yes, I will resolve that on the public GitHub before I get too far into it. Down here is our Asteroid database. So this is the conversion of the Google Sheet that has all of the configuration options for each of the asteroids, their weights, the sizes, distance, computation required, the modules that are required for everything, for all of the different asteroids. I believe there's 41 different asteroids. This is the optimization matrix. So this shows the different weights for the different outputs, the drones that are required or needed for each one to mine up. Down here is our priorities for each of the dust targets. Some of these may not be completely correct, as I haven't had the opportunity to get too far into mining. I'm only in UEV, and I haven't gotten mining modules Mark III, and nothing higher than a drone Mark 10. So these may not be completely accurate. If you find a bug, please log it in GitHub, and I'll take a look at it and update the configurations, or you can update them yourself. So what you would want to set here is the priorities. So lowest number, highest priority, 10, lowest priority, or a 0 will also be a lower priority. This configuration blacklist that's listed here, we can't set the configs for the filter list within GTNH using OpenComputers. So this is something just as a reference for things that you may want to not mine up. And you'll just set your mining module to do that, or you can have your ore processing subnet take care of those. Here is the dust stock thresholds. So these config conditions here at the bottom of the file, this is where you'll set what you want dust-wise or gem-wise, and this will target those particular ones. 2 dashes in front, those are comments. So you can have many different dusts that you want to target. Keep in mind that your typical ore processing workflow is going to be mine it up, send it to the processing subnet, but the integrated ore factories process that, spit it back out as dust, and it goes into your dust subnet where we pull the telemetry from. So there will be a lag period there, especially if you have your integrated ore factories only processing 8,000 ore at a minimum with your stocking input buses or your advanced stocking input buses, automatically pull 8,000, 16,000, whatever have you. So there will be that lag period for the ore to get to your threshold in your advanced stocking input bus in your integrated ore factory, and then there'll be the processing output as well. So here I've only targeted a few diamond, nether star, cosmic neutronium, and I believe uranium-238. Things to keep in mind here, this diamond, so diamond is only in a gem form, so it will look for just the diamond. Salt is an outlier. So salt has multiple forms that are named salt within GTNH. Since I'm using the display name, it will register either the salt dust that we need for pretty much everything, like for chlorine, but it will also register the gem version of salt. So keep that in mind. This is not 100%. This is a work in progress. Again, if you have any issues, please feel free to post them into the GitHub, and I'll take care of them as soon as I can. The rest of the things here with the configuration settings, this is nothing too terribly complicated. We send all the telemetry over port 2026, and then all of the commands if you have a multi-node mining setup. So you have a broker and then you have multiple job nodes. Those commands for the jobs will be sent over port 2027. And then we recheck every 30 seconds after we run a job to see if the dust levels have recovered. Logging, we do log to a temporary file that'll be in space mining. This is a RAM disk file, so this will eventually get large enough and it'll roll over at 64K. One of the other things that we can do with this module, and I have it in my working copy, is I use Grafana Loki to send logging for. This is disabled by default, but if you are really into statistics and you really want to pull telemetry, you can actually send the data over to Loki in a particular format, and that's in the logger.lua. Again, it's disabled by default, but that is an option if you want to build dashboards or something like that. It's really helpful for troubleshooting that I did when I was building this. So you can log it to a file, you can log it to the console, or you can log it to Loki. So that takes care of the broker configuration. Okay, one more configuration to go through, and this is going to be the job node configuration. So if we edit the job node config, this is where we have information about the particular nodes that we're working with here. So in this case, my first broker job node is called Medina Ring 1, and I have the shared database address there in the config file. The tech modules will load that if it has a blank value in it or the default value. I've also filled in the first mining tier or the mining module information here. So I have the module address for the mining module that's on top of it. I have the interface address, which for the adapter that's facing the ME interface. And then I have the transposer that's between the input bus and the ME interface, along with the side configurations. Here, the interface is on the north side of the transposer, and the input bus is on the south side of the transposer. And now that I have this done, what I'll do is I'll show you a run of this working with it configured. We're going to do threshold mode, so this will mine the lowest target first. If you did rarity, it would mine the higher priority ore first. So I'm going to select 1 here. We're going to start the broker. If the mining modules are already running, you'll see that it'll show a clearing state for your different modules. Here we can see we're loading an infinity catalyst. We've got 192 infinity catalyst dust. I'm not doing ore proc, so this number will never change, so it'll continue to mine. We can see here that we've assigned it to the database. We've assigned it a buffer, which is the ME interface, and we've loaded the items in 6.9 seconds. We see other information here. What we target next, we've only got 1 module. We're only going to cap this at 1 asteroid. So for any asteroid that's been targeted, it will do half plus 1. So if you have 4, it'll target 3 different jobs simultaneously. If you have 6, it'll target 4. That way we don't monopolize on a single asteroid and a single mining for a single item, so that everything can go up, so that you're not completely focused on one. Roadmap, I will probably add a feature in here that will just flood all of the modules for a single requested dust, but that's again roadmap item here. We see the radon plasma is already in the system. We see all the drones and the drill kits. So let's go take a look at this mining. So we follow the cable over. We have our transposer. We can see that it's currently mining. If we back out of this, you see the transposer has pulled out the mining drone. We'll wait here for a few seconds and we'll see that those all get set in. We can look at the miner. It's running. We can see that it's got a distance of 91. It's got 4 parallels. We can set the overdrive to a different value if we really want to. Here I will. And then the values and ranges and things like that, we're targeting just a single asteroid. So we're going to let that run. And so that'll run. It's going to go through an entire stack, 16 rods, 16 drill tips for each run. And we'll get 4 runs out of a single item movement. If we look down here, we'll watch this again, wait for a few seconds for it to kick off, load, kick off, and then it will pull the drone back out. And we can see here that the bus has been cleared. So if for whatever reason it leaves too many of them in there, it'll pull, the transposer will throw an error and it'll pull it back out to reset the mining mod. Now that I have the mining module running, what I'll do is I'll set up another node for mining, or another mining module setup. What I'll do here is I'll do Control Alt C to break out of the module. We'll see here, it just throws a stack trace. I'm going to clear it. I've already hooked up the other module. So now I'm going to do detect module. We can see here that it found a new module. Found a new module for the adapter for the mining module. It found a new adapter for the ME interface, and it found a new adapter or a transposer for the input bus. Now the default is it's always going to do the last one that was configured. So in this case, north was 2, south is 3. We're going to say 2 here. And we're going to say enter for 3 here. It's going to propose these changes for module 2. We're going to say yes. Go ahead and write that. And now it'll pick it up. So when I run broker in Mark 3 again, we'll have 2 modules. We'll say threshold. And now we have 2 modules. Now let's go check on those. Now, of course, none of this will run until we pull all the telemetry in. But now if we come over here, we fall in a hole. See that things are starting to get loaded. 91, distance is already set. Turn that on just. Now if it errors out, it takes 30 seconds and it'll throw a different error. So cleared it out. All 3 go in. Should run, if I have this set up correctly, 1500 computation a second. Don't have any radon plasma. I just use a stocking input bus here to insert that. Again, it errored out because it couldn't successfully kick it off. Now it can. We're mining. And now we've got this running. Now I'm bringing you into an error that you may run into, especially depending on how you have everything hooked up. So you'll see here, I went ahead and added a 3rd mining module to the 2nd one. And you'll notice it says unrecoverable error, too many components connected to the computer. This is that limitation where a single mining module, if you don't have the server rack with the creative tier component bus assigned to it, or component assigned to it, you'll get this because there's a 16 or 18 or 20 node limit on a tier 3 case. So I'll show you what I'm actually running into. This is a nice troubleshooting step for you. I have the cable here. It's picking up this wireless connector, this blue one. And the way that I know that is if I break this cable over here, come back over to the console, I'm just going to turn it off and turn it back on. And we do, one of the things that should be part of the download is list components. You'll see this AE multi-P. This is AE multi-part. It's picking up the wireless connector. So what we want to do is prevent that from happening. So the easiest way to do that is break this, move this up, and we'll just do the relinking. So Q over here to our blue node, bind it. Now, we look at our components again. I love it. It hasn't updated. It's this adapter is actually wireless. So we can just remove it, pick up a color. I don't think I have, oh, I do have one. Or up. Top there. That. Doing. Let's check before we bind it. You'll see that. But if we come over here, that should be gone now. Yeah, see, 17. That's gone. Let's re-add it. Pick it up again. So this adapter is actually seeing cable. So we can do a little bit more configuration. Get it to look like that. Verify that it's 18 components. So now we can rehook our cable back up. Now we see everything. Let's rebind. And finally, let's confirm that we have all of our cables hooked up. Our other adapter, got our other adapter, and we've got our transfer. Make sure that we're getting computation. Make sure that we're getting radon plasma, which I forgot the last time. Make sure that we're turned on. We are. Perfect. Come over here. We're going to run detect module. Here again, it found the third module. So we're going to pick the same defaults here. Tell it to write. And rerun the broker Mark III. Threshold mode. Picked up module 2. Picked up module 3. Our cap has moved to 2 because that's half plus 1. And now we're mining cosmic neutronium, infinity catalyst, and cosmic neutronium again. We come over here, we can see that they're disabled for now. They're probably clearing on, and one should trigger now as well. We've set a distance, 61. Now we're mining. We're each pulling in their ores. So there we go. We come over to the input. We can see that we are mining up a lot of ore, ready for our integrated ore factories to process. So again, these telemetry nodes won't update for the dust because I don't have any dust to update it with, but we can see all of these are sending in or information. And neutronium is here. We don't have anything other than neutronium, so it won't show up. And we've got everything mined. Got our overall not hooked up to the subnet, but hopefully that that does give you an idea of how to use this. Again, if we look at we think about how we're doing this now, it's much easier. This is computer controlled. If you do deploy the broker as a single node and you do a computer rack with the creative component bus, you'll be able to run all of the nodes, all the mining modules in a particular space elevator with no issue because we have that 1024 limit of components. So adding the 3 for each one does not interfere with that. So you'll be able to run that with a single database tier 3 and a single node. And then there'll be another version of this that'll come out that'll have a job broker where it'll be a little more involved, where we'll actually have the job node will be sent by the broker, or the job node process will be sent by the broker. So I hope that was helpful for you. And if you have any questions, there is a topic in the description for the tips and tricks on the GTNH Discord. Feel free to send me a message there in that particular topic. And again, any issues that you come up with, this is a work in progress, and I'm always happy to update as needed. So happy mining and happy GTNH. And thanks a lot. Bye now.